Good evening, parents and students. Okay, I'm Kadir Muhyiddin. Today is a briefing on physics and combined science. Okay, so I will get started. I hope most of you have taken your dinner, so you have all the energy, right? I'll share the screen. All right, I hope you can see my screen. Okay, so this briefing is on physics and combined science. I believe there are parents of students taking physics and combined science in Sec 3, and maybe even some students doing physics and combined science in Sec 3. Okay, again, my name is Kadir Muhyiddin, and tonight we'll just have some discussion of what it means to do physics in Sec 3 and Sec 4, and in preparation for O levels. All right. So, what is physics? I mean, if you take a look at this, I mean, we all have an idea because we know that, there are three branches of science, right? Physics, chemistry, and biology. And so, what is physics? Why do we learn physics? Basically, physics is the branch of science where we actually find out about how, simply put, how things work, right? How things work, or the interaction between man and objects, or the interaction between objects and objects. Like if you take a look at this, right? I mean, this is a site that we see during the National Day parade. So here a person is on the parachute, and why does he need to deploy the parachute? We all know, I mean, if he doesn't deploy the parachute, it is going to be quite very risky. Okay. So he needs the parachute, but what's the physics behind it? Okay, so we learn about what's the physics behind it. What's the reason he needs to deploy it? Okay, when he falls, what are the forces? Okay, no questions like speed, velocity, acceleration. So we learn about that. Okay, what are the forces acting on the person? Okay, what happens when he falls? There's the weight acting on him. And then when the parachute is open, how does it help? Because there will be an upward force, there's an air resistance, and actually, this air resistance starts increasing to increase as the speed of the person increase, and eventually the air resistance will be equal to his weight. And then when that happens, he no longer accelerates, so he reaches what you call a terminal velocity. So you see, physics, like in Sec 3, one of the earliest topics, right, is to learn about this. Okay, it involves things about speed, velocity, acceleration, and also all the forces involved. And not to say this is the first time students are going to learn about forces and speed velocity, right? You would have learned it in Sec 1, Sec 2, right? You have learned it. Okay. And also you have learned a little bit of forces in primary level as well. So it's a continuation, but of course in Sec 3, Sec 4, we go at a slightly higher level. That means we understand and we are able to explain things better. Now, if you take a look at all the other diagrams there, basically it tells you what are the other branches of physics that we will be focusing in O level. So you can see there's that steam, can see that kind of steam mist kind of thing, right? When you heat water. So we'll be talking about thermal physics, the idea of why, or of course, we already know water becomes steam, but what happens? Why is it that during this process, why does the temperature remain constant? Okay, when a liquid changes to a gas, or the other way around, or when a solid changes to a liquid, why is it that the temperature remains the same? And it has got to do with the fact that, all the energy supplied goes into, like, for the molecules to break apart. Okay, so all the energy goes into like getting them further apart. So the temperature does not increase even though heat is given. So things like that. And then you can see here the prism with light falling on it. Okay, and then you can see there's a dispersion, right? Just like the rainbow. Why does this happen? Okay, so the idea of refraction, why the speed of light actually changes when it moves through a medium, and light is made up of light of different wavelengths, colors, different colors or different wavelengths, and each one has a slightly different speed. And because of that, it bends, all bends slightly differently, right? So they all don't bend at the same angle. So you get actually this splitting of colors. Okay. And we also learn about sound waves, general properties of waves. So, and the last one there is, of course, electricity. Simply put, when current flows, you get it's converted to like light. I mean, electrical energy is converted to light, heat. I mean, that's practical electricity. We also look at circuits. Okay, what happens when you add more components in series? Why is it that the components in at home or even the office, why are they connected in parallel? What's the reason? Because like when one fails, I mean, we already know that. Okay, when one fails in series, everything won't work. But that's the reason things are connected in parallel. And we also talk about about the electrical consumption. Okay, these are the things that, I mean, these are just some of the things, right? I'm just highlighting some of the things. But generally, if you see these four pictures, these are the main themes that we'll be covering in O level physics or even combined science physics, which is forces and dynamics, which includes the questions on speed, velocity, acceleration, forces, pressure, turning effects of force, work, energy, power. Then we do thermal physics, about two, three topics. And then we do waves, light, sound waves, electromagnetic waves, and then we look at electricity and magnetism. We also learn about electromagnetism. Now, the interesting thing for O-level students is right now, we also, the new topic they've been doing for the last 2 years is radioactivity, right? Okay, that's just what about physics. So I'll go a little faster. Okay, what are we covering today? I'll just briefly touch on the format of paper, the physics paper, and for some of you will be doing combined science, so I'll cover both physics and combined science physics. Yeah, the overview of the syllabus. Okay, what is the syllabus like? Common challenges and how to excel for physics. Just the physics component of it, whether it's pure physics or combined science. And we briefly take a look at how mind structure supports the learning of physics. Okay, how the student can excel, or what our materials like to help in the to do well for physics. Right. First, I think it's important for students to know what is the final paper that they're going to sit for, or the format of the paper lah. Okay. So the final exam for the O level, right, consists of a multiple choice paper, which is carries 40 marks. That means there are 40 questions, 40 MCQ questions, and the weightage of it is 30%. That's 30%. So the MCQ is 30%. That's quite a lot, right? And then the structured and free response paper carries 80 marks, and that's 50%. So that paper is basically all your structured questions, okay, which you will answer both qualitative and quantitative questions. All right. So, of course, there will be spaces for students to work out. I think all of you know what I'm talking about. Okay. That paper, the weightage is the highest. And then for O level, there's, of course, the practical component. Okay. The marks is about 20. This is for pure physics. The one that you're seeing here is for pure physics. The weighting here is for practical is 20%. That's the exam that students have to do. And normally the practical paper comes almost 2 weeks before the start of written papers. Okay, so students have to be, will be prepared for the practical as well as the main paper. All right. So what is being tested? Now for papers 1 and 2, when I'm talking about papers 1 and 2, mainly the MCQ as well as the structured paper, you break it down into two, which is the knowledge with understanding. Okay, simply put, these are your qualitative questions. That means the students need to write the scientific concepts. They have to Let's say, for example, it says describe, state, define, which is partly recall. Not just recall. Recall is 15%. That will be the easy question. But there will also be the explanation, description. Once it comes to explanation, it becomes a little bit more challenging. Now, the knowledge with understanding does not mean these are the easy questions. These questions are also challenging because besides that 15% or about there, the other 30% requires quite a lot of the what is the student's understanding of the physics concept. Okay, we can get it easy with all the definitions, right? We can just, even though we don't understand, we can get it right. But the like state the laws of motion and things like this. But once it comes to describe, explain based on this law, based on this concept, now that will be the challenge. And of course, the other one, handling information and solving problems are the mainly the quantitative questions where you need to do some calculation. There are typical calculations where the formulas will be involved, where you have to look at some data, analyze the data, make some prediction. Okay. Again, this question not necessarily like A and B, not necessarily B is harder. Just that B is more calculation, is mainly calculation. A is more like all the qualitative, right? So it's just for us to understand the two types of questions that are tested. Now, for the benefit of those doing combined science, I just put it here. So for combined science, the multiple choice, again, 40 marks, they will be split into 20 marks of physics and 20 marks of chemistry or 20 marks of biology, depending on what you do. Most students will do physics and chemistry, but I'm just letting you know, right? And then there is also the structured and free response paper for physics that 65 marks that carries 32.5%. And then the one for chemistry or biology also carries 32.5. So, like let's say you combine physics and chemistry, your total marks for the main paper will be the written paper will be about 85%. 65 for paper 2 and 3 plus 20 for paper 1. That's 65 plus the practical will be 15%, right? Okay. Just again, same thing. If this is for combined science, just now I gave you about, just before that, I was telling you about the knowledge with understanding, right? And handling information. Now, this one is for combined science. For combined science, the knowledge with understanding is 50% and 20% allocated to recall. And handling information is 50%. And handling information and solving problems is 50%. Now, generally, of course, because a student who does combined science needs to get both physics and chemistry, right? Even though the paper 2 and 3 are separate, okay, the content wise, in terms of topics wise, they have to end up learning more topics because there'll be some topics of physics, some topics of chemistry. But in terms of the difficulty level of the questions, of course, combined science will be a lot easier in comparison, all right? In comparison. All right. So just to highlight again, what do we mean by knowledge with understanding? So it clearly tells you here the candidate should be able to demonstrate knowledge and understanding in relation to scientific facts, okay, laws like laws of motion, like the Newton's first law, second law, third law. What are the concepts, the definitions, like what is defined resistance, the definition of it. So eventually, like what I said, the students the requirement is to answer questions like define, state, describe, explain, or outline, that kind of thing, right? Now, when it comes to handling information and solving problems, okay, it can have a different a series of questions, but mainly typically it's just using the physics formula, applying the correct physics formula and solving. That will be quite most of it, actually, most of it. But then again, the problem is a lot of students may not be able to recognize what to use in certain types of question. Like, for example, there's something called a data analysis question also, right? So sometimes to locate, select and organize and present information from a variety of sources, okay, or to use information, that using information to identify patterns and things like that. So that can be a bit of the challenge for handling information and solving problems, okay, but with lots of practice, okay, I repeat, with lots of practice and going through this whole sequence of things many times, students actually become confident along the way, right? They will actually pick up. Now, of course, the struggle could be also with certain topics. Some topics will be easier, but some topics are a bit harder. That's why certain topics are taught earlier. Certain topics are taught earlier to actually allow the students to take time to build the concepts. Okay. So as I said, questions like predict, okay, deduce. The word itself sounds a little more, in a way, challenging, right? Predict, deduce. So you have to make some kind of inference. Okay. Calculate is a little, is more direct, right? Or even determine. But the word predict, deduce, or suggest uh, can be a bit challenging for students. Right. So the other important paper is the physics practical paper. Now, whether it's pure physics or combined physics and chemistry, the things that are mainly assessed, right? It's like students are given a set of instructions, right? So you follow that set of instruction. There will be some apparatus. You actually set it up. Okay, that's what it means by manipulation. That's what it means by manipulation. Okay, measurement, to set it up and then to take measurements and or to record observations, right? So and that is one important skill. In fact, that's the main skill tested for practical, because you must be able to do the first part, right? To set it up and take measurements, and after that, once you got measurements, you present the data in a table form, or after that, or you plot a graph, or you just, it can be recording a set of readings in a table, okay, or just recording one set of reading, repeating that set of reading, okay, to take the average of it, okay, to plot a graph, to find the gradient of the graph. So all these are what I'll say is presentation of data and analysis. It includes the analysis of the data, the graph plotting and all, or doing any calculations with it. It's the analysis. Now, after you get all that, you should be able to draw a conclusion. That means come up with a conclusion based on the data, on what the result means. If it's a straight line, is it some kind of a direct relationship between two quantities? And also to make any evaluation. Evaluation could be how can this experiment be better, or what are the precautions for this experiment? What are the limitations of this experiment? The student is supposed to suggest. Okay, so yeah, this is where it is. Like what the student needs to do is to follow a sequence of instructions, use the apparatus, okay, record observations, okay. Now there's also one more thing. There's also the planning component. Now the planning one is, I mean, again, students will be taught this after they do a few experiments. They get an idea of all the different types of experiments. They learn a bit of the concepts. Now, there's a small part of it, about 6 marks, where students must be able to plan an experiment based on the conditions that are given. Normally, what they'll do is they'll give part of a short experiment, and then from there they'll say maybe these two quantities or three quantities, three variables are related like this. So you have to write. The student has to write an experiment based on what they said, how they are related, and using the apparatus given to suggest how to write a short, like maybe about half a page of how would you carry out this experiment to find the relationship between two quantities, right? So that will be the planning part. Okay, so yes, I mean, we spoken about it. Yes, the physics part, I mean, as much as it can be challenging, we need to know that it is also fun, right? I mean, that's the reason why we are learning all this. There's a lot of fun involved in learning this. Okay, now let's try to understand what is the syllabus, right? What is the syllabus for pure physics? What are the topics that we are going to learn? Okay, so for like say for mind stretcher, right? Right now we are at dynamics. Okay, right now we are at dynamics. Okay, but if the for student who would have started sec 3, the school with will probably be at physical quantities, units, and measurements. They could be finishing this, or they some schools could be somewhere halfway there. And then the next important topic will be kinematics. Okay, next important topic will be kinematics. So dynamics is I mean the kinematics and dynamics is what I was talking to you about, the guy on the parachute and all things, right? Okay, and the laws of motions all come there, and then the turning effects of forces, pressure, work, energy, and power, all these comes under what we categorize as Newtonian mechanics. Okay, so that is one big chunk, and by the time schools finish this, right, it will probably be close to end of July. Okay, depending. Now, there are some schools that might just do this the other way around. They might do some other team. But as far as I know, I'll say about 90% of the schools will always teach Newtonian mechanics first. Okay. So for mind stretcher, at this stage, we are at dynamics. But not to worry if you are, let's say, students have missed kinematics because we will be we will be going through all these topics again very soon. Okay, so what we do is continuously, right? When we teach something, we don't just keep going. Okay, we will go back to recap. Especially the first couple of topics are what I call challenging topics. It takes some time for students to grasp it. So you can take note of it, like kinematics and dynamics, right? Uh, Fun topics, very fun topics. Okay, students like learning it, but at the same time it also is these are challenging topics, so students can actually have difficulty answering. I mean, eventually they will, I mean, they should be able to answer some of the basic and what I call the moderate difficulty level questions along the way, but sometimes to fully grasp the topic it takes a bit longer. Okay, now the thermal physics is a bit more straightforward. Okay, it's even though we are talking about slightly higher level stuff, thermal physics, because it's mostly qualitative in nature. Okay, not much calculation. Not to say that the concepts are easy, but students don't really have a problem with this, except for maybe thermal properties of matter. Right. And then you can see the other one is waves. Okay, waves. We'll be learning general wave properties that includes sound waves. That includes sound waves. Okay. And we learn about electromagnetic spectrum. Okay. And of course, light. So light is, I would say, the big topic here. Again, the of the all the topics there, light and maybe some aspect of general wave properties can be a bit challenging. But light has concepts like refraction, total internal reflection. Okay, we also learn about the different, like, the image formed by lens when the object is placed in different positions. Okay, so for the converging lens to draw the ray diagram, okay, and find out what kind of image to get depending on where the object is placed. So that topic, again, for mind stretcher, how it goes is we will cover light after we finish. Okay, just to go back here, right? Mind stretcher we will cover in this sequence. Okay, we cover in this sequence, and by the time we do thermal properties of matter, it should be somewhere in July, end July. Okay, and but we will cover light. We will cover light because that's the harder topic. So we cover that right after thermal physics. And then for general wave properties and electromagnetic spectrum, we will cover it maybe towards the later part of the year. But some schools, we will cover general wave properties towards the end also. So what we'll do is we'll cover this at least before the school exams. Okay, but what we consider as all the harder topics, right? The harder topics we will cover earlier, right? So that students build that foundation. Now, for electricity and magnetism, now this is the big chunk that most schools will teach in the start of Sec 4. Okay, so a lot of Sec 4 students will be learning this now. Okay, and for Mind Stretcher, right now we are somewhere at DC circuits. Okay, we are at DC circuits. Schools are around current of electricity. So we are always like one topic or just one and a half topics ahead, so that the students, when they cover what they cover here, and then when the school covers it, they have that slight advantage of having gone through like maybe 3 or 4 weeks of that topic. Okay, so they have that some sort of a prior knowledge, so that it gives them that little bit of advantage when they cover it in school again. Now, again, the hard topics here are DC circuits. Okay, I would say DC circuits are is the hard topic. Okay, electromagnetism, electromagnetic induction. Okay, normally they will ask one of this, but students take a while to grasp it. But this, just by the order of it, uh, we will cover it towards the end, because it is students will not understand this unless we cover the first few parts of electricity. And it makes sense in some sort of a sequence. Okay, like what I said, there are one or two schools which might do electricity earlier, depending, but mostly 90 to 95% will follow how the mind stretcher follows most of how most of the schools do it. Okay, and then radioactivity will be the last topic, which is the new topic that have been introduced the last 2 years. So we cover that right at the end. So radioactivity is good for those students who do chemistry, right? They also have quite a bit of sense of the atom, what's inside the atom, like the protons and neutrons, the nucleus, and why does the nuclei actually undergo radioactive decay, right? So what actually happens? So that understanding is good when they have that overall picture. Now, what you see here are for combined science students. Okay, these are just the physics topics. Okay, so like what I said, the combined science students have, in terms of topics, they have got a lot more to study. Right here, of course, they have 16 physics topics. I'm not showing the chemistry topics, but this is just to get an idea of the physics topics alone. So for mind stretcher, how we teach it is um, we will do like 2 weeks of physics, and then we'll cover one topic, and then the following week, after 2 weeks, we will do 2 weeks of chemistry, or 2 weeks of chemistry, or 3 weeks of chemistry. So we cover topic by topic. So we toggle between physics and chemistry. But what we'll do is we'll cover one full topic, and then we'll move to the chemistry topic. And then once the chemistry topic is done, we come back to the physics topic, right? So we go in that kind of sequence, okay? All right. Okay, I've spoken quite a bit. Do you have any questions at this present moment? Please feel free to ask questions in the chat. I'll answer. All right. Okay, just to understand, are there any combined science students here, or parents of students doing combined science? You can tell me in the chat. Okay, so we come to the other main. Oh, okay, nice. Okay, doing combined science, huh? So yeah, I hope it's useful, because I'm trying to cover both aspects of, because we are talking about physics in general, but some students do it in combined science as well, right? So I just want to give you some feel of it for both. So that's why the briefing covers generally physics, but also for pure as well as combined science. Now, the challenges faced, I think that's important because we need to know that the course, whether it's combined science or pure physics, it's not difficult, but it has its challenges. Okay, it has its challenges, and students do the challenges are real. Okay, the challenges are real. Okay, so the common challenge or the difficulty students face, right, is I would say the first one here. You can see that concept non-understanding or not understanding the concept at all. Now, some students can go through like an entire year or even up to Sec 4. They may not have actually fully grasped the concept. Okay, they may not have fully grasped the concept. So they can still answer questions. The thing is they can still answer questions, but they don't know that they don't know that they don't actually know the full concept of it. Okay. Now, that's one. Okay. But if they do know that they don't know, then that's fine. That's good. Okay. At least they will know uh, the issue. Then there's the other one, which is a misunderstanding. That means they start to form a totally different idea of what that thing is. What that thing is. Okay. So, like, I give you an example. Like, see, you talk about Newton's third law. Last time, when I was in school, they always say that for every action, there's an equal and opposite reaction. To be honest, right? When they said that, we take it as, oh, for every action, there's an equal and opposite reaction. So that's how we understood it. Okay, but did we fully grasp it? I would say no. Okay, like we did it because they gave us some examples. So it's thought, okay, this for this action, this is the reaction. For this action, this is the reaction. But it was only later, right, when they actually started putting it like for when an object A, now how they write it is when an object A exerts a force on object B exerts an equal and opposite force on object A. So if I were to put it in with an example, if I say if John pushes the wall pushes back on John with an equal and opposite force. So the idea is still action reaction pair, but we are being more clearer here. John on wall, wall on John, right? So that idea, you see, I may actually give these examples a few times, but I can tell you that there will be students throughout the course who may actually struggle to comprehend this fully. Okay, even though they can just by memory, right? I can clearly say what is the action reaction pair for weight. Now, the common misconception, there will always be a lot of misconception. A lot of students will think that the action reaction pair or the like weight is actually the force that the earth exerts on earth, right? But a lot of students will have this idea that it is actually the force of the ground. That means the normal contact force. So this is a common misconception. Okay, I'm just sharing based on the idea of what is a misunderstanding or non-understanding. So they keep thinking there's the normal contact force, but in actual fact, though it may be a bit hard to accept it or even reason it, but it's actually is the action reaction pair for the weight is actually the force. Like let's say for example, weight is the force Earth exerts on me, then the action reaction pair is the force that me exert on Earth. So you see, it's Earth on me and me on Earth. So a lot of students actually find it difficult to accept the part that we actually exert a force on the Earth. Okay, because we don't really imagine that. We can't think of it. We can't really see that, right? Okay, like we cannot relate. That brings that point here. Cannot relate to real life and can't see the link. Okay, can't see the link. So to accept that fact that we are actually exerting a force on Earth, right, may take some time. Now, some students may not even accept it, but they will just write it as an answer. Okay, so things like this. Now the other problem is, of course, they may know the formula, they may know what topic it is, but sometimes they just don't know that for that particular question, that this is the formula required or this is the manipulation required. So that is also a big, because they may know their work, they would have studied for it, but once it comes to that question, right, they look at it, they know it is from this topic, but they don't know how to start or what to do. So that is also a problem, and that problem uh, actually gets solved. That's quite a bit of a problem, but that problem also gets solved through practice, lah. Okay, through lots of practice. And sometimes, when you start, especially at the beginning stage, right? They will find physics a bit complex. So some students, if they keep not getting things and then they don't do well, then they will they will lose motivation, and then they will have this thing that, oh, maybe physics is a very difficult topic. Okay, so they will start having that confidence. They'll feel that maybe I can't do well for this topic. So there are students like this, yeah. I mean, it can happen for any subject, but I'm just saying, right? So, and when all this happens, right, they might actually, even though they might like physics, some students actually like physics, but because they find it difficult to at the start, they might eventually, kind of, not like that. Even though they like what they are learning, also they find it complex and all, and along the way, because of not doing well, they lose a little bit of interest in it. Okay, so that these are just highlighted some of the challenges here. Now, for combined science students, right, as I was telling you, there's physics and chemistry. Um, so while the paper itself is easy, but the content together is quite a bit. I mean, that is the challenge. The students have to study that, right? There's quite a bit to study. So then they will actually find maybe one of it, like chemistry easier or physics easier. So there's this like two groups. Some find physics easier because there's less content, easier to apply. But some students will find chemistry easier because they can understand it better, and then it's like more like they can memorize a bit and answer. So it all depends, lah. Okay. So, and of course, there's also that combined practical for physics and chemistry. They have to do one physics practical and one chemistry practical. Okay. So it has its own challenges. Even though the final paper might be easier, like what I said, the content itself could be not difficult, but a bit more, right? So just to highlight what are the problems students face are like the lack of understanding, okay, or misconceptions, okay, and they cannot see the link to real life. And sometimes when they cannot see, they just take it as a routine. They cannot see the relevance of what they're doing. So, imagine versus somebody who can really see why they are learning this, what is that application, so that interest will be there. Okay, I'm not saying all students can, they do. I mean, there are a lot of students who do it well, but yet they may not see the connection. Okay, but there are some students who will be wondering what this whole thing is all about. Okay, that can also be a challenge. Like what I said, that the main thing is always cannot apply or solve problems. Okay, and then when it comes to the qualitative questions, uh, because they have like part understanding, okay, or not full grasp of the concept, they may not use the correct words or the scientific terms, okay, because of this lack of understanding, or sometimes not even knowing what they're asking. They may actually have the knowledge, but you see, that's why the knowledge with understanding, which I was talking about at the start, they will have the knowledge because they've studied it and they have done it a few times, but they have not seen that this knowledge is what is required for that question. Okay, this is the knowledge that is required for that question. So that again could, be a problem. Okay, when it comes to answering qualitative questions, right? and the lack of keywords and scientific reasoning. Okay, again, very similar to not having a full good grasp of that whatever topic or the concept, certain concepts. Yeah, and which all can lead to student being not motivated and losing a little bit of confidence in the topic. Now, when I say here, I'm just saying in just for physics, but it can apply for other subjects also. So these are, uh, I mean, there are of course certain parts that applies to physics itself. Okay, the practical itself can be a bit challenging. Some students may not take the practical very seriously, but all these, yeah, all these can be solved. The simple trick to it, right? Okay, this personally like maths, physics is actually uh, maths also has certain concepts. See, you grasp a certain part on how to do. You can actually grasp it in 5 minutes. Okay, some students grasp it in 5 minutes. Some students grasp it when they actually do questions. Physics can have a combination of all these also. That means you read your textbook and resource, you read your mind stretcher notes, okay? You the teacher teaches you. So all this knowledge comes to you. You watch the maybe some videos, you do some practical, you watch some hands-on demonstration, okay? Mainly reading, when you read, you have some idea. And then when you practice, you can practice with guided solutions. That means maybe you may not know how to solve a question yet, but when you look at what I call certain examples and how they solved it, how did they approach that question, how did they go about it, so you get an understanding. Oh, okay, all right, this is how they did it. So it's like something like teacher do, or you actually see how that person has answered that question. So you go through that again, and then you actually use what I call we do. Okay, I mean, these are terms that they use from primary to secondary, right? That means the teacher and student can do, or the student can do with all the other resources. Now he's not looking at the solution, but he knows that all these things are available to him, but he can practice with all the other resources. It can be the textbook, it can be the TYS solutions, it can be his school's papers with answers. So all these are there, but he's not going to look at it, but he will practice. And what he can do is he can do it like an open book as well. This time around, the practice with guided is he really look at the answers and do. But this time, he will be finding for all the resources. Like as simple as if he forgot what is the definition, he can go back and read the definition and then apply it. If he forgot the formula, he can go back to the formula list or that topic and find out what's the formula. Okay, so this is what I call practice with resources. And so you notice everything here is practice, 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 right? So it's just for physics, it's really like that. So finally, it'll boil down to practicing. Like let's say, for example, you have the mind structure questions. There's a whole lot of questions there. You can do your school papers. You can go do past year papers. Okay, you can do TYS papers. And some students will be thinking, do I only get a TYS like in my O level year? That means a lot of schools will say, please get your O level. I know TYS in the fourth year, but actually you can get the TYS in Sec 3 as well. Okay, because they also have topical 10-year series. So you saw the list of topics that I mentioned earlier, right? So you can do topical practice to get a hang of what the O level questions look like, to get the feel. So you see, when you practice, right, you practice both MCQ. Okay, that's a different skill set. Okay, and also practice the structured questions. So both type of questions, right? Now, ultimately, right, you see, it's all a cycle. Okay, it's all a cycle. For a student, right, to do well, he must also like it starts off in the class and his own initiative. He can read up, he can do this, he can read up before listening, before that subject is taught in class, or he can listen in class, come back and be curious to read the textbook and resources given, the notes given. And then it starts from there. And then that interest to practice, you may not get it right, but that's why I say practice with guided solutions to get that confidence building. Okay, this is how it goes. Do a few questions, and then slowly go to the part where you don't need to look at the solutions. You try to find for your resources. And then when you are very confident, you don't need to look at the resources. You don't need to do it like an open book. You can just answer it. You get the full picture. You can, I mean, you don't need to wait for the full picture to just practice just like that. But more or less, you get into a comfortable position where okay, I am ready to do all these questions. And of course, in between, looking at resources is never an issue, because that's only going to help you do better. So just very quickly, how to improve the grade, right? You need to find out the topics that you're weak in. So you see, just now I told you, naturally there will be some topics like kinematics, dynamics. Okay, I'm just roughly telling you based on students what they said are their difficulties, right? So dynamics, kinematics, these are tough topics for the Newtonian mechanics. Maybe thermal properties of matter. Okay, some students may have difficulty with the calculations there, and what actually how to answer some of the explanation questions, right? For the topic of waves, light, certain aspect of light can be challenging. Certain parts of, let's say, general properties of waves, okay, sometimes can be hard, right? Okay, and when it comes to electricity, DC circuits, okay, some students have difficulty analyzing combination circuits. Okay, that one. And maybe, of course, like what I said, electromagnetism and electromagnetic induction. Okay, those topics can be difficult. So identify. I mean, of course, I'm just telling you the common topics here, but they are depends on the student also, right? So find the topics that you're weak in, study the topics well. Okay, make your own concept maps, mind maps to how you see this whole thing, right? And then put your thoughts there, right, to link up the content. Well, it says memorize the content. Well, I would say physics, yeah, more than memorize. If you go to that process, right, of practicing with guided solutions, practicing with resources, you don't exactly need to memorize. If you go to that sequence, that information or the concept will slowly start to form. Okay, this is not like, say, biology. Okay, or even to some aspects of chemistry where you have to read the content and memorize, remember it. Okay, but physics is like through that sequence of practice, that concept has to set in. Okay, of course, when it comes to writing qualitative, yeah, you have to have some uh, keywords and how to phrase it. Okay, so practicing using the topical TYS 10-year series and school exam papers. Okay, this could be later. Okay, this could be later, but it can start as soon as maybe about because it's topical, right? You can start it like even in about 2 to 3 months time. Okay, because by then they would have covered some of the important topics as well. Now, remember when you do practices, right? Write down the important points along the questions before writing the answers. So this is to give you some kind of like, you have all the keywords there, or even the formula. What do you think is expected? Then before you actually write out the, like for the questions on knowledge with understanding, okay, what do you want to put in there, right? So, and eventually you should also learn from your mistakes. Okay, like when the paper comes back, right? You will, let's say you got some parts wrong. It's important to learn from the mistakes, or what are the things that you have missed out in your answers, or what did you get wrong in your formula. Okay, or did you get your formula wrong? Did you get your substitution wrong? Did you get your, let's say, which aspect did you get it wrong? Okay, so you learn from it. Did you get your units wrong? Okay, so there are students, right, very good students, but they pay least attention to the idea of units. Just because of units, they keep losing 1 mark, 1 mark, 1 mark, that kind of thing, right? Okay, so now we come to the materials that MS has, right? So MS materials, how it goes, right? how we teach is to in preparation for this. So normally our to get that idea, we need the lesson notes, right? So the teacher will go through the lesson notes. So the lesson notes, like, it triggers some of the, like, previous knowledge, what you have learned in secondary one, what you have learned in secondary two, that kind of thing, right? Okay, your past knowledge. So there will be aspects in the notes like that. Okay, to trigger the prior knowledge. Okay, and of course the teacher will tell what are the learning objectives. This you can actually find in the lesson notes itself. Later on, I'll show sample of the lesson notes. Okay, and these are what I call things that you can components of the lesson notes. Okay, definitions, the actual concepts. Okay, formula. Okay, sometimes there's like a small box to show what are the common mistakes students make. So it's to, like, tell the students, oh, these are some of the common mistakes or misconceptions students have. Okay, there's a discussion section where like, sometimes you talk about some real life scenario. Okay, and the teacher will discuss with the student. Okay, so again, this is another box by itself. And of course, we will also do show videos to explain certain concepts, and then we discuss about that. And the worked examples are there. Okay, so the worked examples mostly are for quantitative questions. Okay, so that students know how to apply the formula that they have learned. Yeah, of course, we can't run away from this. Most of the notes is all on the key concepts. Okay, so because without the concept, right, like what I said, for physics, it's all about concepts. If you get your concept right, you are already like 70 to 80% there. Okay, if your concept is strong, okay, it's all about making sure that this concept, no matter which way they are tested, you are able to see that this concept is being tested. So I repeat that. So it's all about that concept. And for you to recognize that it is this concept that is being tested, no matter how the question is phrased. Right. So of course we will have practice papers. So how it normally goes, right? I'll just say the sequence is like this. We'll do lesson notes normally, like, let's say we talk about pure physics. We'll have a lesson notes one, and then we'll do a practice paper one. And then the following week, we'll do lesson notes two, and then we do practice paper two. So that one week will be lesson notes and practice paper one. The other week will be lesson notes two, practice paper two. And then practice paper three could be, like, especially for topics which are much harder, like just now I said kinematics, dynamics, DC, circuits, light. So those topics will have practice paper three. So the questions for practice paper one and two are more direct, and they match the order of the lesson notes. Like whatever we cover in the lesson notes, the practice paper tries to cover according to that section. But when it comes to practice paper three, you will have more exam type questions. I mean, not to say practice paper one and practice paper two are not exam type. Just that the questions are chosen such that it just covers the concept that you've been learning to correspond, to match it nicely. So you can see the link. Okay, I'm learning this and I'm doing questions on this. Yeah. And most of the time, all the practice paper questions are all done in class. Okay. Occasionally, one or two questions will give it as a homework, but most of it, what happens is you practice. The teacher will give you time to practice, and it's either some parts will be guided, some will be your own. You have to try it out yourself, and then there will be discussion. Okay, and then when it comes to the end of the entire topic, right, there will be concept papers to help formulate. Just like I said, the main thing is the concept, right? Is to highlight and to consolidate all this learning. What are the main things that you've learned? Now, while this may actually be a short aspect of the whole thing, okay, but it's important because it's like for student to know, okay, these are all the things that I have learned. It could be a fun exercise like a crossword puzzle or to complete tables. Okay, but still, it achieves that purpose of, like, that's why it's called the concept paper. Okay, so that the student knows, okay, this is some of the things that I've learned here. Okay, So it's like a summary, like it helps as a summary. Our lesson notes also at the end, every lesson notes has also got a list of key concepts right at the last page. Okay, later I'll show it to you. And we also have a homework booster. These are actually meant for students to try this as total independent work. I mean, every week we also give the homework booster for students to try out questions so that they have the confidence to try it out. Okay. And it could be further questions, it can be articles on specific concepts. Yeah. And this is to encourage that idea of trying out yourself. I mean, of course, by itself, it's not enough. Okay. But it's somewhere, it's something, right? And the solutions for this will be put up on the MS e-study buddy. Okay, e-study buddy, right? So when talking about the e-study buddy, even our lesson notes, whatever we cover in class, the practice papers, everything is actually put up in the MS e-study buddy. So that students actually got two chances. One, they can visit these videos, they can watch these videos before the lesson, or they can watch these videos after the lesson. Okay, so and then when they go for the lesson, they have an idea, or after the lesson, it becomes like a review also, right? Now, uh, now the revision notes, we also give revision notes before mid-year exams and end of the year or prelim, end of the year for Sec 3, prelim for Sec 4, okay, and which gives all the, like what I said, revisit all the important topics again. And revision papers, which is like a lot of exam style questions, O level style questions, all carefully prepared so that to prepare you for the mid year and prelim, and also like in between, especially for Sec 4 students and Sec 3 towards the end, right? Students actually do a lot of these questions to get you to apply and apply. Remember, the whole idea is to practice and get these concepts right, right? That's exactly the purpose of the revision paper. Okay, what I'm going to do is show this. Okay, I hope you can see this. Yeah. Okay, just to get an idea. So this topic here, right, is a topic of forces. Okay, parents and students, I hope you can see the screen. Okay, this is the topic of forces. So you can see this is the first set. Okay, we cover, like here, there's a teacher's demonstration. Okay, the teacher will do this demo in class together with students to understand. Remember we're talking about the parachute falling and all that right at the start. Okay, this is to actually talk about which paper will fall first. Is it the one that is crushed or the full piece of paper? I mean, we all know this from experience, which one will fall first. So to introduce the idea of air resistance and other forces. Okay, so and then after discussion, they write out the observations, they write out the observation, and then there's an explanation. Okay, that's just like a prior trigger lah. The word trigger, right? I was talking about trigger, right? Yeah. So this is it. And then you can see here the prior knowledge, what the student needs to, what the student probably knows before, what are the learning objectives for that this set of lesson notes. Okay, and then okay, so there's a video here. Okay, what about what idea of what force is to different people, right? They actually catch people on the street and say, what do you think is force and things like that. Okay, so then we go to the actual notes itself, right? So this is like what is a force, the different types of force. Okay, now this will be quite, we start off with something easier, okay, like gravitational force, the different types of forces. And then we go to how to add scalar quantities. That will be easy, but when it comes to adding forces, or no, that becomes a little more challenging. Okay, so we start teaching how to represent forces. Okay, then the method of doing this, as you can see, it's actually presented step by step, because this is also quite challenging for the students. Okay, and then how to add it, we use simple examples like when they're in the same direction, how do you add it. Okay, these are easier ones. Okay, but then you go to the what happens when they are not parallel. Okay, so this one is, you see, you can see the notes become progressively taken from something easy, go to something a little bit in the middle, and then we go to the slightly more challenging uh, part of the topic itself or the concept itself. Like, how do you add these two forces? Now, this is a little harder. So we slowly start teaching the technique. Okay. So then the steps are shown and so on. Okay. I just quickly go to this part. Okay. So what happens is, and then there's a work example also. There's a work example. This is for the lesson notes. All right. Here, as you can see, right, key concepts. So this is a summary for students on what are the concepts that they have learned for that particular lesson. Okay, then you can see our practice paper, right, consists of both MCQ questions, and in a way, you can see, can you see the terms here, forces, addition of parallel vectors. So it links to the notes. It links to the notes. Okay, addition of parallel vectors. So the questions again start from easy, moderate difficulty, and maybe one challenging question. And normally the challenging question the teacher will guide, right? Okay, so these are MCQ questions. And then this is what I mean by knowledge with understanding. Okay, this is the knowledge with understanding question. Okay, what are the forces acting? Is the student's statement correct? She's saying the right thing. And then, as you can see, the main topic was actually about how to solve when the forces, non-parallel forces are acting. How do you resolve it? Okay, so maybe the teacher will guide question number 7 again, and then maybe number 8 will be like half half. Student do, teacher guide, and then this question can be student do by themselves, and that's how we take the lesson. All right. So, and yeah, we will probably have another question to also give that extra practice. And here it's I think it's a different sort of question, asking about the contact forces and so on. So this typical lesson notes and practice paper. Now the same thing happens in the second week. You'll have topical lesson notes and practice paper. So it's a continuation. It's a big topic, as I said. And then, so of course, it's very similar to what I just showed. And then what happens in the week 3, right? You will have a short practical component. Okay, depending, we don't exactly do a lot of hands-on. We might do some kind of demo. Okay, but still it's useful for the students. It could be a simulation activity, like here I think this is a simulation activity. Okay, it's a simulation activity. All right. And then we go for a more challenging practice paper. So this is the more challenging practice paper to prepare them for harder questions. Okay, and to apply the concepts in different scenarios. And of course, the last one is actually just to show you. Okay, this will be the concept paper. So like a mind map. So they have to actually recall what are all the things that they have learned, and they start filling up this kind of mind map here. Okay, so what is a force? What is the definition? What can a force do? What's the laws of motion? Okay, what are the different types of forces and so on? Okay, yep. So yes, sorry. So what, coming back to this, just we're going to finish. Yeah. So mind stretcher has assessments, the mid-year checkpoint and the end of year checkpoint or the prelim, right? And we also give progress reports where it gives a detailed report on how the student is doing, not just doing for the subject, but also for different topics. It actually gives a breakdown of all the different topics, how the student is doing, to get an idea of which topic they are weaker, so that they know, okay, that okay, I have to do something about this topic. Okay, so of course, what's the importance of doing well in physics? Okay, I mean, it's not just doing well in physics, you have to do well in all your subjects. Yeah, right. So just for requirement, right? To do H2 physics in JC, can say the student thinking about H2 physics. Of course, right now, whether you go to JC or Poly, both routes are equally attractive. Okay, so we don't need to like think that, oh, JC is the way. Okay, because with physics, if you do well for physics, there are a lot of courses in Poly, right? Also, which if your physics is solid, you go into a lot of courses in poly, you're going to do very well as well. Right. So I'm just briefly telling you about what is the requirement. Okay, for if you do combined science, you need to get an A1. Okay, to do physics, H2 physics. I think they can be a bit flexible, but mostly A1. For physics, the pure physics is a B3. But I know some JCs are flexi. I'm just giving you an like the average or the main requirement. Okay. All right. So yep. So we are basically done. Okay. So what we covered is the format of the paper, the syllabus, some of the common challenges faced by students, and how they can overcome it. Okay. And of course, we also looked at even the physics practical and all that. Okay. And we also look at the mind structure materials and how mind structure prepares students for physics. So yes, physics is interesting course. Okay, it's an interesting course because students are going to like it. They're going to really like it. But at the same time, it can be challenging. But this challenge can easily be overcome. All right. Okay. If you have any questions, yeah, please do ask in the chat. Yeah. Parents, students, if you have any questions, you can ask in the chat. Sorry, I think we may just exceeded about 5 minutes. Sorry about that. Right. So yeah. So if you have no further questions, yeah, no questions. I think that's it. Okay, for today's sharing. Okay, there will be other uh, webinars help which you can also join and find out more. And this, I think the video of this can will also be put up somewhere, and then you can also access it. Okay, so I wish you all the best, and also for students, yeah, all the best for your course. Okay, and enjoy physics and do very well. Thank you very much, everyone. Good night.